Hey guys, welcome back to this tutorial on mains voltage sensing. Now this is tutorial part 4. In part 1 we discussed the circuit, we designed the circuit. Part 2 and 3 we did the PCB layout and we talked about the settings that you can do in order to generate the Gerbers and also manufacture the PCB and also do the settings for etching. Now what you see in my hands here is the result of the etching. So we've now etched the PCB as you can see right in front of you. Now I'm just going to go quickly into the components. I hope you've watched my tutorial on PCB etching because I explained how to do the etching process there. I did not have time to record the etching process for this particular one, but we will do some of the more etching in the upcoming tutorials. Now, before we go any further, please guys, if you like this tutorial, if you find anything useful, don't forget to subscribe to my channel and give the tutorial a thumbs up. That will be highly appreciated. Now, what you see here is the PCB that we've done the layout, okay? So if you look at the part 2 and part 3, we have a connector. So this connector here is the input for the AC. Now this is the cap dropper board that we've designed. Now the input is going in through a fuse. You can see this one here is an SMT fuse. Now I've got the 2 resistors. So now I've got 2 resistors, the discharging resistors for the cap dropper. This is the capacitor that we are using. I'm not sure if you can read there. This is a 224 nanofarad 400 volt capacitor. Now we already did a calculation for this capacitor. We're getting a current range of around 16 milliamps. Now the input to the bridge rectifier, as we can see here. Now on this board I do not have the MOV connected on this board because this is just a test run. We don't have to place a MOV because we're not going to have a surge voltage as we're testing, hopefully. Now the bridge is rectifying the voltage and is going into the capacitor. Now the 2 inputs here, now the 2 points here are where the capacitor is supposed to be connected. As you can see here, I do not have the capacitor, so which means the circuit is working. I've tested it already, it's working, but it's operating without the filtering capacitor, so which means we're going to have a high ripple DC voltage on the input of the opto coupler here. You can see this is the opto coupler, and this one here is the 1K resistor on the input of the opto coupler, and on the output of the opto coupler, this is where we have our low voltage circuit, and this circuit here is the one that is controlling the on and off of this relay here. Now I forgot to talk about the Zener diode. So the Zener diode is connected on the other side, that is on the top side of the board. Here we can just see the pins of the Zener, so you can see that it's between the negative and the positive of the bridge rectifier. Okay, so then as you can see, from this point to this point there is no electrical connection. There is no electrical connection whatsoever under the opto isolator here. No connection between this side and this side. That is exactly why the circuit is called an isolated circuit. Now I've already explained the working of the circuit when we were doing the circuit design and layout. That is on part 1, 2 and 3. But I'm just going to run quickly on the low voltage side here. So what will happen in the absence of the mains voltage, that means we don't have a voltage on the output of the bridge rectifier, so which means the opto isolator is not being biased, the LED, the internal LED. So what will happen then is this relay here have the battery, okay, the 12 volt battery will be connected, which is connected on the normally connected pole of the relay, and that is passing power straight through this bulb here that will be running on a 12 volt battery. So which means in the absence of the AC mains, the normally connected is going to put on the bulb. When the AC mains comes back, so we're going to have actions. So that means there will be a voltage that will be regulated from the 5 volt Zener diode, and That 5 volt Zener will then bias the LED inside the opto-isolator that we've talked about, and that in turn will set up a bias at the base of the transistor, and the transistor will then switch on, turning on this relay coil. So when the relay coil turns on, it switches the poles of the relay from the normally connected to normally open, so which means it's cut off power from the bulb which is being powered from the 12 volt battery. This one here, okay? That means this one will then be on. This one will be on because why? We've got the mains AC that is coming in from this input side, okay? And when mains AC goes out, this bulb will go off and this one will come back on because the relay will switch back into the normally connected. Okay, so this is how this circuit is supposed to operate. Now, I've already said that there is no capacitor here. This is a capacitor that normally is supposed to be connected here that I did not place while assembling this circuit. Nevertheless, the circuit is working, so it's just working with an unregulated voltage. So which means the 5 volt that we've got here, if I can probe it on the scope, will be 5 volt unregulated because we're not putting a smoothing capacitor. So if we have to connect the smoothing capacitor, it will go on like this. So we'll have this capacitor connected like this because we got a 5 volt Zener diode. So which means the capacitor could be anywhere from 16 volt higher. That's up to you. 220 microfarad, no problem. The circuit will still work. So now let me just solder this capacitor here quickly and then we can test this circuit again with the capacitor connected. Okay, so this is an electrolytic capacitor, so which means while soldering this cap here, you need to respect the polarity, okay? That means the longer legs, because there is 2 pins here, the longer one is a positive one. Now from my bridge rectifier here on the schematic, we know that the capacitor is placed between the minus and the plus. So this is the plus on the side, so which means it's gonna go from the top side of the board this way. Like that. Now I can just put it down there and solder it. Okay, just press it flat on the board like that, and then finish by soldering the other side. Okay, if you are more than welcome to watch my tutorial on basics of soldering tips and tricks, then you can just cut these pins out because we don't need them. Okay, so now we've got the capacitor that is now connected on the output of the bridge, and that will be smoothing the voltage. So now we can say that we've got a regulated 5 volt that is going into the opto couplers just to make the circuit more stable. Okay, so now we can go ahead and start powering up our circuit and then to get it working. Okay, so now we can go ahead and plug the battery. Okay, so you will realize that you'll notice that when I connect the battery, as soon as I connect the battery, the bulb here, which is running from the backup, will come on. As you can see, it comes on. Okay, now I'm going to test the voltage that is on the terminal of, now on the input terminal of the battery. You can see there it's 13.4, and if I test also on the output here, it's exactly the same thing. I just have my probe reversed there because it's a polarity voltage, it's a battery. Okay, so that gives me also 13.3 volt. That is straight from this battery here. Okay, so that is powering the backup. Now this multimeter here is connected from my input mains. Right now the input mains is off, and again guys, this is a dangerous experiment because I've got the mains voltage here, and if you don't know how to handle the mains voltage, please don't attempt this because if you shock yourself, it's gonna be a catastrophic problem. You can seriously get injured. Okay, so I'm going to switch on the AC mains. Automatically after switching on the AC mains, this bulb that is running on the backup is going to go off, And that's exactly what happened. And if you look at the multimeter here, that is measuring the voltage on the input of my AC that is coming from this connector here, these blue wires here, that's my mains. Now I'm measuring a voltage of 232. That is 50 hertz, 232 mains power, mains voltage. So what this means right now, we don't have power outage. So our backup light is off, no power outage. So we are running well, there is no problem. Now if I go on and measure here on the DC output, you can see I'm now measuring 0 volt. I'm now measuring 0 volt on the DC output, and obviously because the light is off. Now you realize that the AC mains bulb just went off and the power is still 230. We don't have a power outage, and the reason why is because this bulb here have an ambient light sensor inside. So the room where I'm recording now has enough lighting, so which means the ambient light is automatically going off. But if I just toggle it, mind you, this one also comes on, so my backup is still connected. Now if I bring it back, now the bulb is back on. So if it stays on again for another minute or so, the ambient light will automatically turn it off because it's a ambient light sensor bulb. Now, I just wanted to demonstrate by testing, putting my probes onto the DC output here. Okay, be very careful if you're going to run this test because we've got mains here. Now, when I switch off my mains, you can see my voltage also is coming back here, 13.3 volt. As soon as the mains come back on, this voltage goes to 0 and this one come back to 230, and then we have mains on, and then mains goes off. This voltage here is 0, there's no mains, and this one come back on. So this is how you can basically build a simple backup lighting. Now the only problem with this system here is you have to have both installation running in parallel. So basically you have your mains lighting installation, and you also have your backup lighting installation. So which means this bulb here that's running on 230 will not run on the 12 volt. But if you make a mistake of taking this 12 volt run bulb, you put it on a 230, then you're gonna see the magic smoke. So you have to distinguish that. But there are circuits that you can implement so that you can use only one bulb for the two systems, but that will be a very smart circuit. So this is not a topic for that subject. Okay, so that is it, guys. If you like this tutorial, you find anything useful about it, please subscribe to CMTEQ channel and give a tutorial a thumbs up. Drop a comment on the comment sections, ask a question, and I will attend to it as soon as possible. Thank you for watching. Until next time, cheers.